Good afternoon. My name is Huiwon Lim, and I'm Assistant Professor of Graphic Design at Iowa State University. Today, I'll be sharing a studio project titled Learning Through Play. This project was developed within an interdisciplinary user experience design studio and explores how digital, physical, and spatial interactions can be integrated to support learning and engagement in public environments. This project was conducted in UXD 4400, UX Design Research and Emerging Technologies, a course within Iowa State University's User Experience Design minor. The course focuses on applying UX concept, research method, and prototyping techniques to complex real-world design challenges. The course is organized around three core learning objectives. The first is developing a strong foundation in UX research. The second is design translation and prototyping. The third is communication and collaboration. These objectives shaped how the studio project was structured from the outset. For this project, my students worked with a real-world site, Blank Park Zoo in Des Moines, Iowa, a community learning environment that combines education, recreation, and exploration. The zoo presents genuine complexity for UX design. Visitors must navigate a large outdoor environment, discover exhibits and activities, balance learning with entertainment, and engage across both physical and digital touchpoints. Rather than treating the zoo simply as a backdrop, the studio positioned it as what we might call a learning landscape, a public environment where design can meaningfully shape how people explore, engage, and discover. When we talk about UX design, screens are often the default frame of reference, but many of the most consequential user experiences extend well beyond the screens. In this studio, we approached UX design as the integration of three interconnected layers: digital interfaces, physical touchpoints, and spatial context. Meaningful visitor experiences emerge not from any single interface, but from the relationships among these three layers. To make this framework tangible, my students examined real-world precedents. The Disney Magic Band ecosystem demonstrates how a mobile app, a wearable device, and the physical park environment can work together to create a seamless, personalized visitor experiences. And a couple of museum examples show how immersive digital installations and interactive exhibits can deepen engagement with physical spaces and collections. These precedents help students move beyond standalone interface thinking and toward the design of connected experience system. Because the project targeted children in grade K-5 as primary users, playful learning became a central design principle. Research supports the value of these approaches. Interactive environments have been shown to encourage exploration, participation, and learning among children and families. Rather than delivering information passively, playful experience invite active engagement. So this framework was not simply a design aesthetic. It was a pedagogical stance grounded in the literature on children's engagement with digital and natural environment. They also followed a structured UX process, beginning with site observation and problem discovery, then moving through service blueprint, persona development, ideation, prototyping, and iterative refinement, culminating in a final experience design proposal. This process provided a shared methodological framework for both teams, while leaving room for each team to identify distinct opportunities and pursue different design directions. Right, I will now walk through each team's work in turn. The first team named their project Blank Box Pulse. Their focus was on developing a zoo-wide interactive digital experience that would encourage children to explore, exhibit actively, and collect knowledge along the way. This team consisted of 4 seniors, Spencer and Ben from Industrial Design, Anne and David from Graphic Design. The team's process began with a structured site observation, visit Blank Park Zoo in order to understand context as well as find the pain point. These pain points, however, also revealed clear opportunities. The team identified 3 directions: modernizing wayfinding through digital navigation tool, updating signage to be more visually engaging and accessible, and introducing gamification elements that could transform a zoo visit into a goal-driven participatory experience. To supplement their observations, the team conducted user interviews, asking visitors about their experiences, navigating the zoo, engaging with exhibits, and imagining what interactive features might add value. The interview data reinforced what observation had suggested. Their research phase also included a literature review on zoo visitor engagement, and a key finding from this literature review informed the team's approaches. Based on their observation and interview, the team developed 3 user personas representing their primary and secondary user. So Grace represents the youngest tier of their target audiences. Guppy represents an older child. Martha represents the caregiver. These personas anchor the team's design decision in specific, grounded user needs. The team synthesized their research into a problem solution framework organized around 4 key touchpoints: outdated signage, low visitor engagement, navigation challenges, and inconsistent exhibit information. The service blueprint maps the complete visitor experience across 4 layers: user actions, touchpoint, front of stage interactions, and back of stage processes. The visitor journey begins at the front desk, where families check in, sign up, and receive the wristband. The wristband is paired with a mobile app and communicates via RFID with exhibit and kiosk throughout the zoo. As visitors explore exhibit, the system delivers trivia, collects badges data, and tracks progress. The journey concludes at the gift shop, where collected tokens can be redeemed. This blueprint was instrumental in helping the team think beyond individual screens toward the design of a coherent end-to-end experience system. With the experience architecture established, the team developed the visual and interaction design system. From there, the team developed UI components, navigation pattern, button systems, overlays, and illustrated a 5-step user journey showing how visitors would move from exploring the zoo map to locating an animal, to engaging with a kiosk, to scanning their wristband, to complete trivia. One of the distinguishing features of this project was the development of physical prototypes alongside the digital interface. The team designed and 3D printed 2 physical devices, a wristband with a nature-inspired foam, constructed from a silicone band and polymer body for comfort and accessibility, and a scaled kiosk model designed for durability and ease of interaction in a high-traffic outdoor environment. The context rendering shown here places both devices within the actual zoo environment, demonstrating how the physical and digital component would work together. The mobile app enables zoo-wide exploration through four core features: an interactive zoo map with location marker, trivia tied to individual exhibit, a park paw token collection system that reward exploration, and a pulse gallery that tracks collected animal characters throughout the visit. These interfaces, the wristband and the kiosk, form a connected experience ecosystem. The second team titled their project Interactive Experience. While following the same overall process framework, they identified a different opportunity space within the zoo and developed a distinct ecosystem of site-specific interactive installation. This team consisted of 5 seniors, Peyton and AJ from graphic design, and Alex, Jake, and Hope from industrial design. They also began their process in the same way as Team A, with the observational field trip to Blank Park Zoo. Their contextual research surfaced background information that informed their design direction. This team also conducted a more detailed section-by-section analysis of the zoo space. Their site observation identified several areas with strong atmospheric potential, but limited educational or interactive. This approach yielded rich, location-specific insight that directly shaped their proposal for site-embedded interactive installations. So this team synthesized their observations into a set of key pain points and opportunity area, including inconsistent and low-quality information signage, limited engagement opportunities for younger visitors, the short visitor duration requiring any digital experience to deliver value quickly. Finally, these findings grounded the team's design directions with 4 specific sites: the bat cave, the tiger hood, the aquarium, and the rhino. They also developed 3 personas representing their target audience. And these personas were developed with a particular attention to the short visit duration identified in their research, informing a design philosophy of quick entry, layered engagement, and optional depths. The service blueprint maps a more spatially distributed visitor experience. The visitor journey moves from entry and exhibit discoveries through a series of experiential activities and animal learning interactions to the gift shop and the exit. Key touchpoints include display signage, iPad, interactive media, and television screens positioned at specific locations throughout the zoo. The first major design proposal was Tiger Talk, a site-specific interactive storytelling kiosk designed for the zoo's tiger exhibit. The kiosk features a bench-scale structure with embedded tablets and animal-themed physical elements, including tiger-shaped speaker, housings, and interactive surfaces. Visitors can engage in a simulated conversation with a tiger character, listen to animal facts, and participate in guided storytelling interactions. The form factor was designed to feel like a natural feature of the exhibit environment rather than an added-on digital interface. A deliberated integration of digital content with spatial and environmental design. Their second proposal, Underwater Imagination, addresses the indoor aquatic section identified as high potential in their site observation. The installation features a custom-designed drawing table fabricated from wood with embedded tablet screens positioned within the aquarium environment. Visitors can draw their own fish on the tablet interface, which are then projected into a shared animated underwater scene displayed on a large screen. The third proposal, Echo Adventure, is an immersive room-scale projection installation. Visitors make sound, clamping, stomping, or calling out, and circular sound waves radiate outward from that point across the projected environment, revealing hidden insects and creatures as they pass. The concept teaches echolocations, how bats locate prey through sound rather than sight. Because a full-scale installation was beyond the scope of student project, the team used AI-generated imagery and a short web-based demo video to communicate the interaction, which you can see here. The result is a proposal in which the visitor's own body becomes the interface, and scientific content is delivered entirely through play. The last proposal is a modular interactive photo kiosk that allows visitors to take photos with augmented reality and Nemo filters. The kiosk system demonstrates how a single interaction concept can scale across the zoo through a consistent design systems, while maintaining visual differentiations by location. The AR filter interface offers a highly shareable, low barrier entry point to digital engagement that works across a wide age range. So this project was designed not only to produce strong design proposals, but to support specific educational outcomes that are central to the studio's learning goals. Through this project, my students participated design thinking as a complete process. They also developed interdisciplinary collaborations. Most significantly, they practiced system-level thinking. Student reflection documented at the end of the project illuminate these outcomes in their own words. One student wrote, "The cross-disciplinary learning was genuinely one of my favorite experiences within this class." This reflection suggests that the learning goals of the studio were not simply met, but internalized. This project demonstrates how interdisciplinary, studio-based learning can strengthen students' system-level thinking and collaborative design skills by connecting observation, service design, and experience prototyping within public environments. Ultimately, this studio was less about designing a specific solution for a zoo and more about developing in students the capacity to think systematically, collaborate across disciplines, and design experience that support learning, exploration, and engagement in complex public environment. I hope this project offers a useful model for design educators interested in structuring studio learning around real-world, place-based challenges, and I look forward to discussing how this framework might transfer to other institutional contexts. Thank you. I welcome your questions and look forward to the discussion.